Hello, everyone. Thanks for joining. My name is Daniel Bigos, and I am lead open source developer at OpenZeppelin, and I've been working on the Stylus smart contracts library from the very beginning. Today, we're gonna talk how to build Uniswap V4 hooks in Solidity, how to optimize those hooks by moving the sophisticated computations to Stylus smart contract, and how to perform upgrades with a beacon proxy. So before we start talking about the deep tech, let's start with a simple question to be on the same page. And the question is, what is Arbitrum Stylus? So Arbitrum Stylus is an upgrade to Arbitrum technology stack that brings another additional virtual machine to Arbitrum chains. And that virtual machine was virtual machine. That addition, that change allows us to deploy any WASM EVM compatible smart contracts. So we can have both EVM and WASM smart contracts on Arbitrum chains. Those smart contracts can call each other. They share EVM storage. They are co-equal. Thanks to Stylus, we have faster execution and lower gas fees. And this is because the WASM virtual machine is much faster than the EVM. Additionally, Stylus brings more security to projects, to protocols, because in Stylus, reentrancy is disabled by default. So if you need to use some reentrancy stuff in your smart contracts, you need to enable it by purpose. You need to change something in the configuration by purpose. Stylus smart contracts are available just like EVM smart contracts in the terms that developers, users can interact with Stylus smart contracts on Arbitrum chains the same way that we would interact with them as they would be just regular EVM ones. Now let's talk about the technology stack around Stylus. So at first, Stylus SDK is a set of libraries, code tooling that enable developers write EVM compatible WASM smart contracts. The most popular one and the most advanced one is Rust Stylus SDK. And this one we will be using today in our workshop. Also, we have a command line tool that is called Cargo Stylus. This is the tool that is used to create new Stylus project, build a Stylus project, deploy Stylus smart contract on network, and do some other stuff. The last but not least is a Nitro node. And Nitro node is just an Arbitrum node that holds both EVM and WASM virtual machine. Now let's have a quick look how to just write very simple counter smart contracts in Stylus. And in order to just start a Stylus project, we need to use Cargo Stylus tool and type new command. This command generates for us just regular Rust project with all the dependencies that we need and all the files that we need. We need to take a quick look into a couple of them. The first one, cargo.tom. This is the file to manage all the Rust dependencies over the Rust project, and of course, our Stylus smart contracts. The great feature around Stylus is that developers can use any existing Rust library that can be compiled to WASM in their smart contracts. The second file, lib.rs, this is the most important file of the project. It holds all the logic of our Stylus smart contract. Additionally, there is main.rs file. This file contains some logic about printing smart contract interface, but we'll touch this topic later. How to define a storage for a smart contract. So just as a regular Rust code, we need to define a Rust structure and we need to use two Rust macros. The first macro, storage. This macro generates for us all the code needed to just use the EVM persistent storage, like read, write stuff. Additionally, we need to use entry point macro, and this macro generates for us all the code needed to make our Stylus smart contract, our Rust track be callable on the blockchain. In other words, that Rust macro gives us the possibility to make all the functions available. Of course, we can define any data type that we want to, that we know from Solidity. We just need to import those types from alloy primitives crate, and that's it. And for our example, we just need to store the current counter value that is unsigned in. Of course, we need to write some logic to our smart contract, and a logic is written in Rust in implementations block. We can have multiple implementations block, as you can see on the screenshot, but I need to point right now in a public macro. So public macro tells which of the functions are available on the blockchain. So on the screenshot, you can see two implementations block, but only functions from public implementation blocks are a smart contract function. So smart contract will have value function, increment function, and decrement function, but set value function will not be available. Of course, our smart contract functions, as regular Rust function, can return a value, can panic, can return an error. Additionally, thanks to Stylus SDK, we have access to blockchain environment. For example, as you can see in set value function, we can read the current message sender, we can emit a log and stuff like that. We talked about events and errors, so let's have a look how to define them. So in order to define both events and errors, we need to use the sol macro from Alloy library, and this macro parses the Solidity syntax, creates Rust structures based on the syntax, and adds all the code that we need to have our events and errors available in our EVM compatible smart contract. So as you can see on the screenshot, I define counter updated event. Also, I define below zero error event. Now I need to mention that each Rust function must have strictly defined return type. So it can return just a value, nothing, or a result that can be success or error. And as in a regular EVM smart contract, our smart contract may return different errors. For example, insufficient balance, insufficient permissions, and stuff like that. So in order to have that condition met, that we need to have strictly defined errors for a function. We need to define error enum that contains all of the possible errors that we defined in sol macro. Thanks to the Solidity error macro, we have a very nice binding between Solidity defined errors and our Rust error enum. So we have implemented very first contract. Now let's have a look how to deploy it. So we can use cargo stylus deploy command. That command sends two transactions on chain. So the first one, it's called deployment transaction. It deploys the WASM bytecode on chain. The second one, called activation, it prepares the WASM binary code to be available on Arbitrum chain, to be available on our WASM virtual machine. Yep. So Right now, I need to mention about a term that may sound weird, and the term is cache. So the initial problem is that the time needed to load wasn't binary from hard disk into the virtual machine takes some time. It costs some gas. So in order to reduce the time and of course gas fees, Off-Chain Labs, the team behind Stylus SDK, brought up a solution called Cache. And Cache is a cache manager contract that holds all the contracts that are available in cache. So we have a quick access to those smart contracts. We don't waste time and of course resources on loading that was smart contracts into memory. In order to have our smart contracts, Stylus smart contracts in cache, we just need to use cargo stylus commands to add the smart contract to cache, of course, place some bit, and we have it. So also, we would like to know how to interact with the smart contract. And this is the time to talk about the main.rs file in our Rust workspace. So in that file, we have only one instruction. The instruction is print ABI. And after invoking cargo stylus export ABI command, that instruction prints the Solidity interface of our smart contracts. So as you can see on the screenshot, these are all the functions that are exported, that are available on our counter smart contract. And you can interact with that smart contract, deployed smart contract on Arbitrum chain, the same way as we would interact with just Solidity counter implementation. Yeah, that's it. If you are interested how to build token standards like ERC20, 721, 1155 with Stylus smart contracts library that we have built at OpenZeppelin, or if you want to learn more about the crypto library that we have built, or if you want to learn something more about Motsu, our unit testing tool, I really encourage you to rewatch my previous workshop. This is the QR code to the link with the previous workshop. So I will give you a minute to just scan the code if you're interested. And now we can talk about our main topic of today's workshops, that are Uniswap V4 Hooks. So for those who don't know, Uniswap is a decentralized exchange protocol on Ethereum that allows many customizations via Uniswap hooks. Uniswap hooks are just smart contracts that are triggered in some time during swaps, during some liquidity operations, and any other operations that are done during the swaps. So right now we don't have Stylus Uniswap hooks, but we can use Solidity hooks to build the logic to trigger the actions, and we can move the sophisticated computations from Solidity to Stylus. And this is what we're gonna do in this part of the workshop. So please scan the QR code to follow what we will do during the workshop. And this is the repository with the Solidity Uniswap hooks. Now let's check how we can build just at first regular Solidity hooks. So we just need to generate Solidity project. We need to install the Uniswap hooks dependency that we built at OpenZeppelin in Solidity. And we can have a look how to at first define just a random hook for Uniswap. That hook will just count the count the amount of swaps that has been performed. So the first function that we need to have a look is get hook permissions, and we need to specify which hooks are available. As you can see, there are a bunch of hooks, like before initialize, after initialize, before add liquidity, after add liquidity. But what is our main interest for this part is before swap and after swap hooks. So we are going to enable those hooks. So we just need to implement those functions before swap and after swap. What those functions do is that before swap checks the current amount of swaps that have been performed, and if they exceed the limit, it reverts. After swap, it just increments the amount of performed swaps. Of course, this is Solidity code right now. Of course, we can write some unit tests for our Solidity smart contracts. We need to provide the setup function to just deploy for us everything, and we can write any test for our hooks in a regular way. At first, we need to initialize the pool and add liquidity. We need to initialize all the currencies that will be used in the swap, and we can just interact with the smart contract in a very simple way by checking the swap number. Also, we can perform a swap via the swap runner, and we can check if the memory of the hook was properly updated. Additionally, we can check if the hook properly reverts after exceeding the 10 swaps. So, of course, initialization, then we need to perform swaps, test swaps. They do not matter. We need to confirm that we have reached the limit, and we can expect the specific error after swap operation. And we can check if everything is as it was before. So this is how developers can implement a very basic hook in Solidity for Uniswap. Now let's focus on our main goal. And the main goal is to implement custom swap curve. And for those who don't know, custom swap curve is the way that tokens are traded. In this workshop, the curve is not sophisticated because it is constant sum curve, 1-to-1, which means that the exact amount of tokens is traded to the same exact amount of tokens. So, for example, we have two different stable coins around USD. So we treat 100 stable coins. We exchange 100 stable coins of one cryptocurrency to one exact 100 stable coins of another cryptocurrency. And we need to slightly modify the hook that we previously implemented. So we just need to keep only before swap hook, because this is the hook that is responsible for adjusting swap curve. Also, we need to enable custom swap curves by enabling before swap return delta hook. And we need to do some stuff around adding liquidity, but it's not the part of the main workshop. So what we're gonna do is to implement the 1-to-1 constant sum curve right now in Solidity. So in before swap function, we have access to, of course, the pool ID. We also have access to swap params, any call data that is around the swap. So at first we need to differentiate which currency of the pair are we trading. So this is the if else that differs first currency from the swap pair and second one. And this is the main part, get amount out or get amount in. Those two functions are implemented in Solidity in the smart contract, and those two functions just tell us how many tokens are swapped to how many. And after that calculation, we just need to settle the swap. And the way that we calculate the amount in and amount out for our swap is that we trade exactly 1-to-1. So amount in is equal to amount out for this swap. Yeah, I know that this is very basic swap curve, but this is only for the demo to just make you aware what is going on. Additionally, we have the stuff for adding liquidity, and that's it. So at this point, we have all the logic implemented in Solidity Hook. But our goal, the goal of this workshop, is to show you how we can speed up the protocol by moving the computations from Solidity to Stylus. And this is done in the next commit that you can check out. And what I have done is that I removed that get amount out and get amount in functions from Solidity code, implemented those functions in a Stylus smart contract, and I added the call from the Solidity smart contract with hook to that Stylus smart contract curve implementation. So I needed to define the Solidity interface of the curve. This is it. Of course, during the smart contract, Solidity smart contract creation, we need to specify the address of the hook. And during the swap curve calculation, we just, instead of calculating it in Solidity, we need to call the Stylus smart contract. So for both inputs. Yeah, that's it. How we can move computations from Solidity to Stylus. Now let's check how to build that Stylus custom curve smart contract. So please scan the QR code to the repository with custom curve. I will give you a minute. Okay. Now we can go to the repository that contains the implementation. And what I did is, at first, I just used cargo stylus new command to generate the project. Of course, I cleaned up the repository. And I started with defining an interface for our curve. So interfaces in Rust are defined as traits. So you can see all the functions needed: get amount in, get amount out, without an implementation, without a logic. It's just a specification of the interface. Additionally, I added definition of the events that we will emit in the hook, also an example of an error, only information about smart contract with entry point and storage macro. Additionally, I added error type to the interface, and this attitude allow developers to define their own errors for this trait, and the only requirement is that these errors can be encoded into bytes. That's the only requirement. So we have the interface specified for our Stylus constant sum curve. Now let's implement it. So as you can see, I added implements macro to my smart contract. Implements macro tells which trait will be scalable on the blockchain. And in our case, it will be a Uniswap V4 curve interface. I also added a constructor to our smart contract, Stylus smart contract, to set a version. I will use it only in the demo. It's not needed in general, but a constructor is a function that is called during smart contract creation in order to initialize properly the smart contract. Yeah, so now it's time to define the interface, to implement the interface for our smart contract. As you can see, I implemented the error type for our smart contract. I implemented the version function. It's just about storage read. Also, I implemented get amount in and get amount out functions that are required for the interface. In our smart contract function, we can call any other Rust function from the smart contract or any library that we use in our project. We can emit some logs from the functions if we want to. And this is our logic for custom some curve calculation. Is traded one-to-one, so amount out is equal to amount in. So the same as we implemented in Solidity, but we have it in Stylus. All right, we have the logic. We should also assure proper quality of our smart contract. So we need to add some unit tests. And in order to write unit test, we are going to use Motsu. Motsu is our unit testing tool that we built at OpenZeppelin. And Motsu adds all the EVM and WASM emulation that is needed to test our smart contracts, Stylus smart contracts. So we just need to add Motsu as a dev dependency with and also arbitrary. And we can write unit tests. So the difference between Motsu and regular Rust unit test is that regular Rust unit test is only with test macro, but Motsu unit test is decorated with Motsu test macro. And in Motsu unit test, we need to specify which smart contract are we going to use, as you can see here. So I'm specifying constant sum curve smart contract that we are going to test. And also we need to provide all the addresses that will be used in our test scenarios. Yeah, so we have everything for the unit test, and of course we can test the smart contract calls execution. As you can see here, I'm calling the contract as Alice. I'm calling the get amount in function with some predefined values. I want it not to panic, and I check if the values are correct. Also, thanks to Motsu, I can assert that proper events were emitted. That's basically it. So this is our Stylus curve implementation. Now we can deploy it and play with it. So I have the Nitro node up and running. I also pre-founded the account to play on the dev network. So what I'm going to do right now is just deploying the Stylus curve. Okay, so this cargo Stylus command looks more sophisticated because besides just cargo Stylus deploy, I need to pass bunch of parameters. The first one is just a RPC URL, so it's obvious. Also, I'm passing the private key that is stored in environmental variable. This is not recommended. It's only for workshop. You can't keep your secrets private keys in environmental variables. Also, we need to specify the WASM file that we are going to deploy. Also, we need to specify the deployer address. The deployer address is the address of a deployer smart contract on Arbitrum chains, and that deployer smart contract is responsible for calling Stylus constructors for newly created Stylus smart contract. So if we want to use Stylus constructor, we need to specify the deployer address. We also need to specify constructor signature. In our case, it's just constructor with one string parameter, and we need to provide all the arguments to constructor, and we are going to provide only the string that will tell us the version. It's v1. And yeah, we have our Stylus smart contract deployed on our DevNet. We can interact with the smart contract. As you can see, I'm using Castcon, which is a tool that is used for playing with EVM smart contract. It works with Stylus. So I just need to specify the smart contract address, function. Yeah, and it works. It returns proper value. Now let's try to call our swap amount calculations. Get amount in at first. Okay, so the other is proper. So I'm calling the smart contract proper function. At the first parameter is the amount out, so it should return the same. The rest of parameters is not important in that curve, so returns the same. We also can call the second function, get amount out, this time 76, return 76. It worked. So just to summarize this topic, in order to have our Uniswap hooks optimized with Stylus, we need to deploy our Solidity hooks, and we need to, during the deployment of Solidity hooks, provide the address of our Stylus hooks. Okay. So we have very basic swap curve implemented in Stylus, but we want to have a possibility to upgrade the curve in the future. In order to not break the protocol, in order to specify just one address of the smart contract of the Stylus curve smart contract, and have the possibility to upgrade it, we can use proxy mechanism. A couple of days ago, there was a workshop around UPS proxy. So in this workshop, I will show how Beacon Proxy works, how it can be used from OpenZeppelin Stylus library, and how it can be used in that specific use case. So how Beacon Proxy works. So Beacon Proxy is done from a couple of contracts. The first one, implementation contract, is only our business logic. So in our case, it is our Stylus curve that we already implemented. Besides that, we have two different smart contracts. The first one, upgradable beacon. This is the smart contract that is responsible for the upgrade. So in Beacon Proxy, the logic and upgrade mechanism is separated. So upgradable beacon is responsible for the upgrade mechanism. It stores the current implementation address. it performs an upgrade, and it should be the access to upgrade should be restricted. In our implementation, it is restricted to only owner. Besides upgradable beacon smart contract, we also have many beacon proxy smart contracts. And what beacon proxy smart contract does, it checks in upgradable beacon smart contract the current implementation address, and it forwards the call directly to the implementation contract. So taking beacon proxy to our showcase. So in our showcase, our Solidity Uniswap hook will call beacon proxy to calculate the swap amount. And beacon proxy will forward the call to implementation contract to just do the calculation and forward the result to our Solidity hook. In the case that we would like to perform an upgrade, we, as an owner, we would need to call upgradable beacon. Now let's have a look how to build both upgradable beacon contract and beacon proxy contract. So please scan the code, scan the link to the upgradable beacon contract. Now let's check how it can be implemented with OpenZeppelin library. So another Rust workspace, another Stylus project generated with cargo stylus new command. First command that matters is adding OpenZeppelin library to the dependencies. As you can see, it's a release candidate that currently is undergoing a security audit, and the new released v0.3 version should be available soon. Also, I modified export ABI feature to use OpenZeppelin Stylus export ABI feature. It adds some code that we use in our library, and it prints the whole interface of both our smart contracts and the code that developers write. Of course, it enables Stylus SDK export API feature by default. Yeah, so this is how developers need to use the OpenZeppelin Stylus library. And now let's have a quick look to the beacon, upgradable beacon smart contract implementation. So as I said, we need to use OpenZeppelin Stylus library. We need to import some interfaces, also upgradable beacon component. We need to define our upgradable beacon smart contract with beacon component. We need to implement all the interfaces. Constructor, as you can see, it's only using the already defined and implemented functions like constructor from upgradable beacon, upgrade to function from upgradable beacon, implementation function from upgradable beacon, and some already available functions from ownable and beacon stuff. So let's play with it. Okay, so this constructor for upgradable beacon takes two parameters. The first one, address, is the address of the implementation contract, and the second one is the owner of the smart contract. Let's check if the implementation address is correct. AB8, AB8, yeah, it's correct. So we can deploy the upgradable beacon contract. It is deployed. we can interact with the smart contract. It has get implementation function. We can just use cast call to play with the smart contract. And the address is here. So as you can see, it returns the proper implementation address. So upgradable beacon right now stores the proper implementation address. Now let's add the beacon proxy smart contract. I'm gonna give you a minute to scan the QR code. And now let's check out the repository. So contract, unfortunately, right now we can't have many smart contracts, Stylus smart contracts in a single workspace. So we need to just have many different Rust projects. So I added Stylus, OpenZeppelin Stylus, the same way I did it previously for upgradable beacon. Let's have a quick look how I implemented beacon proxy. Of course, I imported all the proper traits and components from OpenZeppelin Stylus library. I implemented constructor, all of the functions needed that exists, just exported them. That's it. And right now we can play with the beacon proxy to check if that works properly. So we need to deploy it at first. Deploy. So the constructor for beacon proxy takes two parameters. The first one is address, and this is the address of the upgradable beacon contract, and also some call data. In our case, we won't share any call data to the beacon proxy. We'll just initialize the beacon proxy with the beacon address. Let's confirm that the address is correct. E547. E547. Yeah, so we can deploy beacon proxy smart contract. It is deployed. Now we can interact with the beacon proxy smart contract. At first, let's check if beacon address is properly set. As you can see, the address is correct. Now let's check in beacon proxy if we get the proper implementation address that is retrieved from upgradable beacon. So in order to do that, we need to use get implementation function. And as you can see, it returns the address of the implementation, the address of our Stylus custom curve smart contract. Of course, I can show you how to perform an upgrade. So we need to use upgradable beacon contract. It's here. But at first, we should have a new logic deployed. So I'm going to deploy at first the same Stylus curve, but just another version, V2. So it is deployed. We have the new implementation logic address. so we can perform an upgrade. The new address is here. And the upgradable beacon address is here. As you can see, I'm using cast send because I need to pay for the computations, and I also need to specify the private key to sign the transaction. So transaction has been sent. So as you can see, it is successful. So now let's check the implementation address via the beacon proxy, and we should get the updated address. All right, here it is. So we got the updated implementation address. So this is how to perform an upgrade with beacon proxy. Let's back to slides to summarize how it fits to our workshop. So implementation contract, our Stylus custom curve, upgradable beacon that manages the upgrade mechanism, and beacon proxy that forwards the call to implementation contract based on the address stored in upgradable beacon. And our Solidity Uniswap hook needs to have beacon proxy address, because once it calls beacon proxy, the call will be forwarded to implementation contract. Okay, so now let's talk about another use cases and the power of Rust and Stylus, how Stylus can be used to optimize protocols and stuff like that. Let's talk about the example. So some time ago at OpenZeppelin, we implemented a Poseidon hash in Stylus. Of course, we implemented our own optimized big integers library. We applied some tricks to optimize the Rust code. We also used some tools to optimize the WASM. And we did some benchmarks. So we benchmarked our Rust Stylus implementation of Poseidon hash. We also benchmarked Solidity implementation of Poseidon hash and Solidity assembly implementation of Poseidon hash. And the results that we got are amazing. So our implementation is 18.5 times faster than pure Solidity implementation. It's almost twice times faster than Solidity assembly implementation, but the Solidity assembly implementation is so hard to read and maintain. And with Rust, we have just very easy to read, maintain implementation. And of course, easy to use. Another use cases that Stylus can be used besides, for example, optimizing Uniswap hooks, protocols around Uniswap, are on-chain verification with ZK proofs. Also, developers can build some advanced DeFi instruments in Stylus, or developers can move some sophisticated on-chain logic, as we did today, from Solidity to Stylus. Just to summarize, Stylus gives endless possibilities. That's it for today. Thank you for joining, and don't hesitate to check out our smart contracts library. Don't hesitate to submit any questions to us. Reach out to us via Telegram channel, Stylus Developers, and have fun with Stylus. Thank you for listening. Enjoy.